All right, we're on 5E. We're talking about correlation. Define and distinguish among positive correlation, negative correlation, and no correlation. How do we determine the strength of a correlation? Positive correlation means that both variables tend to increase or decrease together. So two variables are correlated positively if the increase in one leads to the increase in the other, or the decrease in one leads to the decrease in the other. Negative correlation means that two variables tend to change in opposite directions. That means that if one goes up, the other goes down, and vice versa. No correlation means that there is no apparent relationship between the two variables. How do we determine the strength of a correlation? The more closely two variables follow the general trend, the stronger the correlation, which may be positive or negative. Determine whether the statement makes sense or is clearly true, or does not make sense or is clearly false. Explain your reasoning. There's a strong negative correlation between the price of tickets and the number of tickets sold. This suggests that in order to sell a lot of tickets, the price should be lowered. Right? That makes complete sense, right? The statement makes sense. To increase ticket sales, the price should be decreased since there's a strong negative correlation. I've found a nearly perfect correlation, positive correlation between variable A and variable B, and therefore was able to conclude that an increase in A causes an increase in variable B. So this is a big no, right? Because just because two variables are correlated doesn't mean that one causes the other. It just means that, again, as one goes up, the other one goes up. When one goes down, the other one goes down. That does not mean that one of them causes the other one. The statement does not make sense because a correlation alone is not enough evidence to establish causality. I had originally suspected that an increase in variable E would cause a decrease in variable F, but I no longer believe this because I found no correlation between the two variables. This makes sense. Originally, negative correlation was suspected. You thought that increasing one would decrease the other. Since no correlation was found, there's apparently no relationship between the variables. This makes sense. Negative and no correlation. Scatter plot. So here we have two variables, the weight of cars in pounds and city gas mileage, and you would imagine that as the car gets heavier, the gas mileage goes down for the car as it takes more gas to move it. These are negatively correlated. So when it says state whether the diagram shows a positive or negative correlation, this one's negative. It's going down from left to right. And it's pretty strong, right? So what makes it strong? What makes it strong is that how closely it resembles a straight line. If they're all packed together, moving down close to a straight line, then we say that it's strong. So select the correct answer below. We're going to say that heavier cars generally lower gas mileage. There are exceptions, but heavier cars tend to lower gas mileage. Same question for this. Here, instead, there's a weak positive correlation. That's to say that, that as you move from left to right, that the numbers tend to go up, right? So we're going to say there's a weak positive correlation. And we'll say that higher AG may imply slightly higher charitable giving as a percentage of AGI. For the following pairs of variables, state the units that might be used to measure each variable, then state whether you believe they are correlated. Latitude and the average high temperature in June. To measure latitude, the units are degrees of latitude. To measure temperature, we'll use Fahrenheit. And we'll say that there's a negative correlation between them because high temperatures in June tend to increase when the wait one moment. So 7. We're gonna say there's a negative correlation because average high temperature in June tends to increase when the latitude decreases. So when the latitude gets near 0, then the temperature increases because you're nearer to the equator. For the following pair of variables, state the units that might be used to measure each variable, and do what we did before. The age of a person and the time spent on social networking sites. So the age of a person will say, we'll do in years. To measure time, the unit is going to be, we can do probably hours. Let's look at the question again. And then we can say that they are, as the older you get, the less you'll spend on social networking sites. So that means they're negatively correlated. Let's see which one of these fits. The following table gives, so this is called a scatter plot. And let's see which picture fits. So here's the data. Let's see if we can plot it here. So here, this says that 1 should be about 7 and 30 something thousand. Is there one like that? 7. Oh, here's one for 6.5. 6.5 goes to 48,000 and something. So here is 6.5, and this is not 40. This is not 48,000. So it's not this one. 6.5 should be about, I'm sorry, 45,000. So here's 6.5 again. This is not 45,000. It's not over 45,000. It's not this one. Here's 6.5. Again, does not look like it's going to be correlated to 45,000 anything. So it's not this one. It's D. Let's just make sure. 6.5 goes to 48,000, and the other ones, you can check the other ones as well, but the first three just don't fit. Looking at this graph, now looking at this graph here, is there any correlation? Ooh, this one's close. As you're moving from left to right, maybe they're headed up a little bit, right? So we would say, yeah, they don't, we're going to say they're not going to be correlated at all. They just look like they're bunched around. Suggest a reason for the lack of correlation. What are we talking about here? We're talking about the table gives per capita personal income and the percent of the population below the poverty level for 10 states. Why might there not be correlation here? Oh, because this is an average, right? So since per capita income is an average, it would be directly affected by extremely high or extremely low income levels, right? So this is a poor variable to pair with the percent below the poverty line. Do a similar one. Let's test this out. Teacher salary and then per pupil expenditure. All right, so let's test out this first one. So teacher salary, let's pick one. Let's do 70,000. Roughly 70,000 should go to like 15,000. So this is 40, 60, 70 should go to 15. So this is by ones, I think. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Yep. So 70,000 should go to 15, and that does not look like that's happening in either case. None of these are 15,000, so it's not this one. All right, 70,000 should go to 15. Is there another one that's close to 80? All right, so both of these should go to roughly 15. That's happening. Let's check some other ones. A is around 50,000, which is in the middle, and that should go to around 10. Right, this one's looking like this one could be it. Right, we got a bunch. Let's see if the other ones. So maybe it's this one. It might be that one. Oh, right. The other ones don't do this, right? So the other ones are missing these two. We know those two are right, and they're not there. It is B. Process of elimination. So if it's B, B looks pretty. That looks pretty linear. Looks like, look at all of these. These are definitely on a line, right? Or they could be. So that's pretty strong positive correlation. Why might that be the case? If you're paying teachers more, then you're probably paying per student more, right? If you have enough money to pay the teachers, you're probably paying a lot for the students as well. That's not always the case, but they're going to be positively correlated. Consider the following statement about correlation. State the correlation clearly, whether there's a positive or negative correlation. In a large resort city, the crime rate increased as the number of taxis increased. Well, more taxis means more people, probably, and more people might mean more crime. So we're going to say that there's a positive correlation. right? So we would check this one. And then we'll say something like more people, right? So then we'll say this correlation is due to a common underlying cause, because it is possible that with an increase in tourism, both the crime rate and the number of cabs increase. So there could be some other reason causing it. Consider the following statement about correlation. Over the past 3 decades, the number of miles of freeways in Los Angeles has grown and the traffic congestion has worsened. So if more freeways, traffic congestion has gotten worse, that just means that, a reason for that could just be tons and tons of people. So again, they look like they're positively correlated. And then we would say, what is the most likely cause? We would say the correlation is most likely due to the common underlying cause that Los Angeles has a bunch of people. There's a strong correlation between tobacco smoking and the incidence of lung cancer, and most physicians believe that tobacco smoking actually causes lung cancer. However, not everyone who smokes gets lung cancer. Briefly describe how smoking could cause cancer when not all smokers get cancer. And we'll say that again, we have to allow for randomness, right? That not all smokers get cancer because cancer is caused by cell mutation, which is a random occurrence. And while smoking increases the chances of such a mutation occurring, the mutation does not occur in every single person. Hope it helps.